So now, this video is basically a voltage tripler, but there are diodes, so they drop some of that voltage. We don't actually get triple the voltage out, something to be aware of, but people still usually call it a voltage tripler. So we got capacitors here that we charge and pump, and then we got other capacitors that just store the charge that they're given. These are the capacitors that the charge is getting pumped into or drawn out of, either by one of the charge pump capacitors or by a load. In this case, we're just going to use a multimeter, which is going to drain a little bit of current. We'll see the voltage go down. Any case, I just have a jumper that I'm simulating. You would actually use like a digital switch that alternates between the positive supply and ground extremely rapidly if you wanted to make this a practical circuit. It's not intended to be a practical circuit. It's a demonstration circuit, and voltage boosters are pretty cheap. Just get one of those. That's your best bet. But in any case, it's good to know this circuit. So we got the first capacitor right there. That is the charge and the pump capacitor. So with the negative, the jumper here to the negative supply at the negative side of the capacitor. Stuff's also going on over here during this part, but we're not going to worry about that right now. We're going to look at each part at a time. So negative supply, that charges the capacitor. Since we got a diode, capacitor is probably going to charge to about 4.4 volts. And we got, out of that 5 volts, we dropped about 0.6 approximately right there. Now we put it to the positive supply. What that does is you can see that this path here heads to the negative supply right there. It can't go through the diode right there. So we got the 5 volts plus about 4.4 volts. So a potential of about 8.8 volts that this capacitor could charge up to if we pump charge into that capacitor enough right there. So again, this is just a storage capacitor. That's the charge pump capacitor on this side of the circuit right there. Now, its voltage goes up. You can see we got a diode coming to that capacitor. We connect it to ground. That's going to take the charge out of that capacitor, lowering its voltage, raising the voltage of this one right here, going to ground. So we have the potential out of that 8.8 volts, that about 8.2 volts will charge this capacitor right there. This is the charge pump. And then we put it to the positive supply right there. So the charge is not going to go to that capacitor when we go to the positive supply. It will that direction. But with this capacitor right there, we got about the 8.2 volts. We go to 5 volts. You can see we got ground over here. So we have the potential of about 13.3 volts maximum that this capacitor can charge to. That voltage plus the 5 volts that we got there. But it's going to start pumping current into this storage capacitor right there. And so with no load, the capacitor voltage is just going to go up. They do have a little bit of leakage, so it will naturally kind of drift down. With the multimeter, it's probably going to drift down even faster. Multimeter probably has less resistance while it's measuring voltage than the leakage through the capacitor, the amount of resistance it has. But in any case, if there was no leakage anywhere or anything, we could probably get about 12.8 volts out. So we're not tripling the voltage. We're almost doubling it there, and then we are almost tripling it over there, but we have the diode drops. That's the main thing. If you can get rid of those drops, you'll be more efficient. But we're looking at the basic form where you just use diodes right there. And again, if you power a load, that's going to lower the voltage quick. So you got to do this really, really rapidly if you're going to set it up like this using a digital switch going from high to low. And also, you'd want bigger capacitors and stuff too. But we're not going to worry about that. We're just looking at the basic property of the circuit. So now, here we got the multimeter. We're going to measure voltage. This is auto ranging. All I have to do is set it to V, make sure it's DC. And if there's numbers, make sure you put it to a number higher than you expect to measure. I don't have to move the red probe for anything other than high current for this meter. And I never have to move the black probe for this meter, but other meters you may have to move the black probe for one reason or another. So I think to begin with, I'm going to take a 220 ohm resistor right there and make sure that our final capacitor is discharged. Going to go to the negative supply and then go to the capacitor right there. So that should also help drain the other capacitors through the diodes. So you will have a little bit higher voltage because of the buildup of the diode drops. So yeah, we got V for voltage, and we don't have a measurement yet because I have to do the same thing to the black probe. I made these jumpers too. I talk about them in other videos, so I'm not going to dwell on that too much. So there you can see, we got about 5 volts minus the diode drop right there. If I remove the capacitor, it should, basically stay the same. We do have a little bit of leakage that can go through the diode to charge the capacitor a little bit more. Be aware that current does leak through diodes, so when it comes to capacitors, you can charge them to a higher voltage as long as barely any current is moving right there. If they're drawing a load or something, their voltage isn't going to go up. So that's the first capacitor. Now we're going to look at if I put the jumper to the positive supply. There you can see we added voltage to it, and it'll probably go higher if we do this multiple times, and maybe not. Maybe we're stopping at about 7.35. Okay, so yeah, it is going up a little bit. So again, you got to do this really rapidly to really get the voltage to rise quick right there, because some of the current that we are putting into this capacitor is also going into that capacitor. So voltage is not going to rise as fast as it could. Now we come to this capacitor. This is a storage capacitor, although this other capacitor will take charge out of it. So we will see that, again, it's not going to bump up to its final voltage super quickly. It should be about 0.7 volts, 0.6, 0.7 volts less than what we had with this one right there. It's just storing the charge. This one is the other charge pump. So it is coming the negative side of the capacitor, because we got that diode coming from the positive supply. So that's going to be a higher voltage than this side of both of these capacitors right there. So this will be the lower side, since the higher side's on the other side. Now, we are to the other charge pump capacitor. We're to the positive supply, so that's the higher voltage that we're going to get. There we go, the lower voltage. And so now we pumped the, we pumped the current last time. Now it charged from that one. So it's going to be a lower voltage because we are headed to ground through the capacitor. Now we got the positive side on the other side of the capacitor. That's pushing the voltage up. Hopefully that makes sense. So there you can see about 10.5. And so as I said before, I think it was 12.8 volts is 12.8 volts. If I said 10.8, I meant 12.8 volts. And I think that's the maximum we'll get. And there you can see we got, pretty close to 12.8. But you can see that the multimeter is draining it, relatively quickly. This one's the capture one. So again, we got this one. It's not gonna be dropping down. It's just catching the charge from that one, and so it's just gonna keep going up as long as I do this. The meter though will slowly trickle it down right there. And so yeah, again, bigger capacitors will accept more charge, and therefore as the charge leaks through the multimeter, it won't impact the voltage as much. Something to be aware. But there you can see, we're like 12.2 volts. If we're going fast enough, I think we might get to 12.8 volts right there. But we started off with 5 volts at the rail. That's to the negative supply. And then we got, 5 volts right there, just a speck higher right there. Power supply is set to 5.1, but you lose some voltage where there's like connections and stuff. And this might not be as accurate as the multimeter and stuff like that. So I set it a little bit higher, so we got 5 volts, a little bit more than 5 volts, instead of a little bit less than 5 volts, because 4.9 volts looks a lot less, or looks a lot more annoying, than 5.082 right there. So, in any case, that's really about it right there. These are all 100 microfarad capacitors. I think these two, and they might be the same size as that one. They look a little smaller where I'm coming at, but this one's definitely a lot larger than any of those three. So size kind of determines capacitance, but depending on how they're made, it might not be completely dependent on size. Be aware of that. But obviously really, really large value capacitors are going to be, relatively large compared to really, really low value capacitors. So always turn multimeter off when you're done. Not terribly important with the voltage, other than wasting battery. But if you're measuring current ever, definitely get it off of measuring current. Here you have to set it to the off setting. That automatically takes it off. But you don't want to accidentally think the meter is set to measure voltage, and you try to measure a voltage and it sets more current through the meter than the fuse that you got set. If you're measuring current, it's going through a fuse. So that blows a fuse. You got to replace a fuse. It's really annoying. But in any case, that's it for this video. Thanks for watching. Make sure you check out one of the other videos I'm posting on the screen, and check out links down below. They all help out a lot. I'll see you in the next video.